my name is Postart, not Braden. This is the N1000 project that you've seen in the previous video, and we need to make a Rocksim file for it. So let's get right into that.
Crazy that you can do that on my videos, but not your own. What is up, everybody? Thank you so much for tuning into another episode of Rocket Vlogs. And you heard Postart. Today we're making a Rocksim file for the Wildman Falcon 98. This is a ultra high performance, all carbon mostly carbon fiber, I should say. Minimum diameter 98mm rocket. This is a sponsored project from our friends over at Great Western Buildings, and of course wildmanrocketry.com helped us out with it a little bit too. And yeah, it's going to be quite a flight. I realized I may have undersized the chute a little bit, but for the general purpose of things today, we're going to use the chute because today I'm going to show you how to make a truly in-depth Rocksim file and get everything as accurate as you possibly can. I see a lot of people asking for Rocksim files for a lot of kits, and a lot of new kits don't have Rocksim files. There's none being made for them, or the manufacturer doesn't post them, or whatever reason, whether you're doing that or you're custom designing a rocket and you already have fins and everything cut, this is all going to be applicable to you. All you really need to get that aspect of it done is a basic tape measure and a ruler, or I like to just use calipers for pretty much everything. However, if you want to make a really in-depth file, the most important thing that you're going to need to have is a scale, and preferably not one that you broke like mine, but it still does function, so we're going to go ahead and use it today. And we're going to start by taking some measurements. So the first thing we're going to do is measure the tube, because that's obviously the easiest one. And I've been trying to decide whether I want to wear the mic pack and talk through all of this or just do a voiceover. And I'm kind of thinking the voiceover is the easiest option here, right? So I'm going to do that, but let's start by measuring this tube. First and foremost, we're going to measure the overall length of our airframe tube. Then we're going to use that digital caliper to measure both the outside diameter of the airframe and the wall thickness. Of course, we can find the inside diameter by subtracting 2 times the wall thickness. It's a good idea to take notes of these measurements, and while I usually would just do them on the phone, I figured I'd make a nice physical example for you. So with those measurements out of the way, does anybody care to guess what I'm going to do next? That's right, we're going to weigh the airframe tube. While we're here though, don't forget to measure the length of your switch band if you have one. And if you have multiple airframe tubes, be sure to get accurate length and weight measurements for each one of them to keep your sim file as accurate as possible. Now we're on to the fins. You're going to want to measure the fin's root length, tip length, sweep length, and span. Once you've got those measurements, you're going to weigh the full set of fins at once, and then that's it. You're done with the fins. Next, we're going to measure the overall length of the nose cone itself, not including the coupler portion, which is called the shoulder, by the way. Now we're going to weigh the nose cone. If your rocket has a removable coupler for the nose cone shoulder like this one does, be sure to weigh it with the nose cone. While the scale's out, we're going to go ahead and move on to weighing some odds and ends like our bulk plates, our vent band, shock cord, parachute, and even the Nomex protector. If you already have hardware like quick links and eye bolts for your recovery system on hand, weigh those too. Remember, we want everything to be as accurate as possible if we want accurate simulations. One thing to keep in mind about this rocket in particular is that it's minimum diameter, so I don't have a motor tube assembly to worry about here. But if you do, be sure to get accurate measurements of the motor tube's weight and the centering ring's weights as well, and only measure the portions of the fin that will be outside of the airframe. Don't include the through-the-wall fin tabs. And that's it. It really is that easy. That's all of the measurements we'll need to make a nice Rocksim file, and if the handwriting on this piece of paper doesn't kill you, the mixing of imperial and metric units certainly will. Now let's get to the fun part. Alright, let's get this party started. I am using Rocksim. I've just been using Rocksim for my entire life, so I'm very used to it, but all of this should be pretty generally applicable to OpenRocket as well. So we're going to try and speed through this and make it as understandable and painless as possible. The first thing we're going to do is body tube. So we're not going to use any of these database ones. We have our own. First and foremost, we're going to change our inches to millimeters there in those two because that's how we measured them. So 102 millimeter outside. And of course, our wall thickness is 1.8. We're going to multiply that by 2 because there is 2 walls. So it's 3.6. 102 minus 3.6 gives us our inside diameter of 98.4. We're going to keep that open just in case we need to reference it later because it will come back. Next, we're going to put 66 inches for our length. Cool. We're going to put carbon fiber as our material, and I'm going to put unfinished. And of course, this won't be the case for every rocket, but since this is a minimum diameter rocket, I'm going to click this tube is a motor mount. Yes, it defaulted to 98 millimeter. Now, what I'm going to do is keep in mind the center of gravity shows here at 33 inches, but we want the mass to be correct on an independent level per component. So we weighed the tube at 39.3 ounces, and we're going to match that center of gravity the Rocksim calculated for the tube by itself at 33 inches, and click use the mass and CG information below. Boom, there you go. And then of course we have that pesky little vent band. So we're going to paste another one of these tubes, and we're going to click the top one, and we're going to actually change that to our measured weight of 0.9. Now our nose cone. Let's go ahead and do that. We're going to click nose cone, and again, we're going to ignore that. First, we're going to go to fiberglass because the nose cone is the only non-carbon fiber component other than the bulk plates. We just need it to be. That way it's RF transparent and you can actually track a rocket with it. So for the wall thickness, we're going to match it to what we had on everything else, 1.8 millimeter. And for the diameter, we're going to match the external diameter of the tube, which is 102 millimeters. And this is where things get a little interesting about shaping it. We know that this is a von Karman nose cone because that's what Tim tells us. But it's 24 inches. But what I'm going to do is put 22 inches and then a 2-inch base length so that we have a more correct nose cone shape. Next, we're going to come down to the body tube and we're going to add our fins. So this is where things can also get a little bit interesting, and I'll tell you about that later. But first, we're going to do our very basics. The fin thickness is going to be 5 millimeters. And then, of course, we're going to come down here and select carbon fiber. Then we're going to start punching in all the data that we have. We have 11-inch root cord, a 2.25-inch tip cord, a semi-span of 4.25 inches, and a sweep length of 10.5. Now, when you enter all this in, the fin shape's not going to be quite exactly what you want. Sometimes, like this one, those are a little more swept than the real life ones appear to be. So we're just going to click on this guy, the sweep angle, and just roll it back a little bit. I use the wheel on the mouse to get that as accurate as I possibly can. And then for these to be flush, they're actually going to sit about 1.5 inches from the base. So I changed that to from the base of the owning part. This is just telling it where you're measuring from. And that should, put us right about where we want. We want the tips of these fins to be flush with the rear of the airframe. Now, here's where things will get a little bit interesting. We're going to go back into the nose cone real quick, actually, because I forgot to put a shoulder on it. We're going to do 6-inch shoulder because only about 2 inches goes into the nose, and we're going to use 98.4 millimeters. No, millimeters. Because we know that's our inside diameter, and boom, there you go. Now we're going to use this guy as a little bit of a cheating trick for Rocksim here because you can't put a parachute directly in the nose cone on Rocksim. What we're going to do is open this up, and I'm just going to take a lock precision parachute that is close-ish. And the first thing I'm going to do is click from the base of the owning part again, and this is a fun little hack for you, but you can put negative numbers, negative 15 from the base of that 1.5-inch tube. Nope. Sorry, that should be from the tip of the owning part, or from the front of the owning part. My mistake. Negative 15, and boom, our parachute's in our nose cone. What we're going to do here again is our mass override because we weighed our parachute at 4.1 ounces. And this is the data that I have right now, but it is very incorrect because I'm going to need a much bigger parachute, but we'll worry about that later. Next, we're going to do the same thing with bulk plates. We're going to put a thickness of 1/4 inch. Doesn't really matter because, again, we're using a mass override of 2.4 ounces because that's what we calculated. Not pounds. make sure you're paying attention to those units because you've seen me make that mistake several times already. So this one, don't forget to select your material. I'm going to put everything unfinished, and we're going to slide this guy down. About 4 inches. Okay, about 6 inches. Yeah, so we're right at the base of our coupler there. And again, we got all the mass override stuff good. So what we're going to do is copy this guy. And we're going to paste another one, but we're going to move it further forward. Get it on the other side of that coupler. It's not quite reaching, so I'm going to put -1 so that it's a little more aligned with where it will actually be in the rocket. Now, we're going to add another mass object for our Nomex protector. Don't worry about any of that. We're just going to put general Nomex, and we know that it weighs 0.6 ounces. And from the front of the owning part, we're going to put -8-ish. Yep, that puts us right in the middle of the nose cone again. Nom-X. Nice, I put a space in there. Okay. We're going to add altimeter weights now. So I have already created one for the featherweight Blue Raven because the weight is available for that guy on their website. And then we're just going to slide it down so that it is in the middle of our, slide it down so that it's in the middle of our coupler roughly. Not quite, give it a little half an inch. Okay, and then what we're going to do is we're going to copy this and paste it again, but we are not flying to Blue Raven, so we're going to open it back up. And the Fluctus weighs 23 grams. That is the other altimeter we'll be using, so I'm going to put 23 grams and put Fluctus. Boom. I just realized I forgot to put the mass override on for the fins, so let's do that. 17.8 ounces for the fins. Boom. Look at that, moving our center of gravity ever so forward because they're lighter than Rocksim thought they are. And while we're in the fin set, actually, what I'm going to do is change this to rounded because airfoil's not quite correct. Okay. So that, in essence, is this rocket in completion. We got one more mass object to throw on here, and we're just going to put shock cord, Kevlar, and I actually generally don't like to use the shock cord preset, the Altus Metro material. Yeah, I'm going to actually go back on that because it's pretty much never right. And we already know that we're calculating our own mass, except for some reason that's gone now, so we're going to close that. Another mass object. Boom. Okay, it's back. Ounces. Our shock cord weighs 2.8 ounces. And our location is going to be -8, just like everything else that goes up in the nose cone. Now, this rocket is, in essence, complete for now. But you should consider your Rocksim file sort of like the Constitution in that it needs to be a living, breathing document to make sure it's staying completely up to date with what you've got going on. For example, I have a couple more recovery devices that'll be up in the front. Devices, I mean just quick links and general stuff like that. I'm going to weigh each and every one of them and put them in this sim file so that everything is accurate as I can possibly get it. Now, there is one outstanding thing you might have thought of already. It's that we don't have any weight back here to simulate the epoxy that is going to be our fillets. And they are going to be big, big fillets. And there's a couple ways to handle this. The first way is to select another mass object. And this kind of requires you to keep track of how much epoxy you're using. And that can be a little bit cumbersome, but if you want to do it, that's great. I don't know how much epoxy I'm going to be using, but I'm going to estimate about 100 grams, and we're going to put it as close to the center of those fins as we can get them. And this is a great way to do it if you have a rough idea of actually how much epoxy you used. But a great way to do this as well is to make sure you have all of your components individually weighed out if you want it to be broken down like this. However, if you don't want it to be broken down like this and you don't care how accurate the simulation is for how much individual components weigh, you can do this as well and skip all of the steps other than the measurements that we just talked about. All you need to know is the center of gravity of your rocket, and I highly recommend for this step, whether you're using it just to simulate epoxy and paint or the entire weight of the rocket, go out and measure the center of gravity from the tip of the nose to where it is on the rocket. Right now, Rocksim is saying it's at 54.93 inches, and I'm going to trust it for that. What we're going to do is punch that number in, 54.93, and let's say I figure out that the rocket, as loaded, actually weighs in at 9 pounds. Boom, and we have an accurate weight with all of our actual measured weight for the rocket. And from there, you should be able to simulate motors and get a decently accurate simulation, as accurate as you can get. Just make sure that your key figures are the actual measured center of gravity and the actual measured mass of your rocket without a motor in it. If you want to break down all the components by weight like I do to keep things as accurate as possible, it's not a bad call. And real quick, I just wanted to touch on one more thing. If you're doing a motor mount, obviously this one doesn't have one, but you just click on the tube that you would like the motor mount to go in. You click inside tube, and we're just going to put a 38 millimeter motor mount in this guy and make it flush. Boom. And then what's really cool is if you want your fins to be super accurately simulated, you can go to through the wall fin mount, calculate the fin tab depth for me. Then once you have your motor tube in there, all you got to do is click centering ring, and yeah, we'll just grab a 4-inch centering ring. Sure. This lock precision one will do, and then we're just going to throw that there. Copy. Stop that. Paste. For some reason, Rocksim really does not like the Control-C command. And then we're going to open up that second one, bring it up to the top of our motor tube. And, obviously you're going to want that to be accurate to how it is in real life. But I just wanted to give you guys a quick demo of that. Of course, I do not need that on this rocket because it's minimum diameter. And that is it. That's all it takes to make your own Rocksim file. You just need a little measurement. I'm going to throw it back to me in the garage now. And that is it, ladies and gentlemen. That is how you make yourself a Rocksim file. Now, I will admit that the clip of me showing how to do it on the computer that you guys just watched took me 3 takes, and I had to start over every time because of recording issues. So there's a decent chance I would have missed something like adjusting the weight of each component or whatever. But the key element here is that you want to measure and make sure everything is accurate. And most importantly, you want to measure the actual center of gravity of your rocket in real life and the actual weight of the rocket so that you for sure have those 2 elements complete. Once you have that and the correct measurements of your fins and your airframe and all of that, you should be getting very, very accurate sims. Now, this project originally was intended to get cut way, way shorter to just barely fit a 15360 case in there. And we actually decided on lengthening it as leaving this tube full length. And even still, it's simulating to 44,000 feet at Alamosa for NSL. And I received some information from Chris Short, csrocketry.com, that he has flown a few N1000 minimum diameter projects that went pretty drastically over the simulated flights. Because his theory is that the base drag is still minimized. Even though the motor has stopped burning, the motor still burns for a decent amount of time, just not as powerful. It's just not outputting a ton of thrust, but his theory is that the flame front and smoke and everything still being there is still drastically reducing the base drag. I'm not an aerodynamics guy. You guys know I dropped out of aerospace engineering school, but that sounds pretty reasonable to me. So now we are kind of weighing what exactly to do with this flight. I do not want to break the waiver, and it does seem astronomical to think that we could accidentally fly an extra 12,000 feet over the waiver. And this was with RAS Aero settings not completely optimized as a 0 roughness and stuff. It was with the RAS Aero settings at smooth paint, which is what this thing will have, and it was estimating the rocket without a motor will weigh about 11 pounds, which I think it's going to be lighter than that. So this is why simulation is very, very important, and this is why I decided to do this video. Make sure your sim files, especially your fin shape and dimensions and your weight and center of gravity, are correct. This is the ultimate way to ensure that you have proper safety for loading a motor. If you don't have the motor on hand to put in the rocket immediately and check the center of gravity, you can get a very good idea of whether or not that motor is going to need nose weight, or how high it's going to go, or if it's going to take off too slow because your rocket weighs too much. This is all very, very important stuff that brings a simulation into a field of necessity. It wasn't something that really was available, in the early ages of high power rocketry in the 80s and 90s when they first started flying these big composite motors. But because it is a tool that we have and that it's so efficient and works so well in the modern era, it has become what I would deem a necessity to ensure that you're flying rockets safely. So please make sure your sim files are good, and make sure your rockets are pointed straight up. My name is Braden Carlson, and you just watched a Rocket Vlogs video. Hopefully you found it helpful. If you did, let me know what else you'd like to see on these sort of how-to series videos. I'm gonna do one on gluing motors that need to be glued, both long burn motors, in the case of this one in the future, the N1000, and standard grain bonding stuff. I'll do it with my M1675. I also have an Aerotech L2200 that I plan on flying soon. If you want to help support the channel, check out patreon.com/rocketvlogs, or you can click the join button below to join the channel membership for as little as $1 on Patreon or $2.99 a month on the YouTube membership page. All of you guys, I appreciate you so much for helping keep this stuff flowing. Well, through my unemployment, all of your names are rolling across the screen as we're speaking. Of course, you can get the Nigel the Rocket Cat merch now through Airfest at rocketvlogs.com. And that's it. That's all I got. You just watched a Rocket Vlogs video. My name is Braden Carlson. I already said all this. Oh, one more thing, actually. For any car people that are watching this, I have a YouTube channel about cars too, and sitting right on the other side of that garage is a brand new 2024 Ford Mustang GT that Ford brought to me. So if you want to see video content of me playing with cars, check that out. The link will be in the description. Or if you want to see video content of me playing with RC planes and RC cars, that link will also be below. Got a whole bunch of videos and stuff we're working on. We got some really exciting flights. Please press the subscribe button, hit the like button, leave a comment, do all that stuff. My name is Braden. I'm going to stop talking really fast at the camera right now. I'll see you next time. Peace out.